Yeah, today I'm going to discuss about the operation amplifier and its stages. It's presented by Dr. R.J. Venkatesh, Assistant Professor, the Department of ECE, SRM Madurai College for Engineering and Technology, Pottapalayam, Tamil Nadu. First of all, what do you mean by integrated circuits? There is called as shortly it's called as IC. IC is a miniature and low cost electronic circuit consisting of the active and passive components fabricated together on a single that is crystal of silicon. So what is active components? Active components are transistor and diode, and passive components are resistance and capacitor. So the transistors are integrated. Integrated means you can pack millions of transistors and diodes are packed. You can implement the IC. That IC it's performing the operations. So it shortly it's called as IC, right? So the packing technology is your millions of transistors are packed. You can fabricate the IC. So this IC can perform the different functionalities. First, what is operational amplifier? So it shortly is called as APAM. Operational amplifier is a direct coupled high gain amplifier consisting of two consisting of one or more differential amplifier followed by a level translator and operation and an output stages. So the operated output stages. So it is used to amplify AC as well as DC input signals and designed for computing the mathematical functions such as addition, subtraction, multiplication, division, integration, differentiation, and logarithmic operation and anti-log operation. So it's performing the different mathematical functionalities. So it's shortly called as OPAM, right? So it's called as operational amplifier. So what are the functionalities that is arithmetic operations are performed with the help of the operational amplifier? So it is called as APAM. So the mathematical functions are addition, subtraction, multiplication, integration, differentiation, and also perform the logarithmic and anti-log operations. So it is the operation amplifier. The functionalities are the operational functionalities implemented with the help of LM741 IC. LM741 IC is nothing but is a 8-pin IC. The pin configurations are there. Is a pin diagram of LM741 IC. Here the 2 is nothing but inverted input and 3 is nothing but non-inverted input. What do you mean by inverted input? You can give the negative supply to the second pin, and 3 is nothing but non-inverted input. You are giving the positive supply to positive voltage given to positive voltage. It's given to the voltage supplied to non-inverting. So your input is you are given to negative terminal means called as inverted input. And input is given to positive terminal, it's called as non-inverted input. So the output is taken from the 6th pin of IC, and here the 185, these 3 pins are not in use, so we are not using for amplification or any other arithmetic operations. Here the ICs are this is nothing but 12 volt. The IC is operated with the help of 12 volt. So 4 is nothing but you are giving the negative 12 volt and plus positive 12 volt is given to 7th pin. So here only you are using the 5 pins, the 2nd pin, 3rd pin for input, IC supply for 4th and 7th. The 4th you are giving the negative 12 volt to 4th pin, and positive voltage is given to 7th pin. The output is taken from 6th pin. So the inputs are 2nd and 3rd, and output is taken from the 6th pin. So this is nothing but LM741 pin diagram. It is nothing but operation amplifier IC. So what are the stages of APAM? The first we are giving, already told, you have two inputs. One is non-inverted input, another is inverted input. The the output stages. We are taking the output from the output stages. Output stage. Here you have four stages. The first stage is nothing but input stage. You are giving the dual balanced the output differential amplifier. Second stage is the intermediate stage. You can give the balanced output differential amplifier. You get the balanced output differential amplifier. And next third stage is nothing but level shifting stage. Here you are using the emitter follower using constant current source, and the output of level shifting stage is connected to the output stage. The output stage is the fourth stage. It's the final stage of operation amplifier. Complementary symmetry push-pull amplifier is in fourth stage. You get the amplified output. Next one. So what are the each stages? They already told you have four stages of operation amplifier. The operation amplifier consisting of multiple stages, each responsible for different functions, ensure the high gain, stability, and proper output characteristics. First stage is nothing but input stage. You have differential amplifier stage. The first stage of operation amplifier is a differential amplifier. It's amplify the differential input terminals. And I told you have two terminals in operation amplifier. One is inverted terminal and one is non-inverted terminal. So both the inputs, suppose we are giving both the input to both the input means you give second and third pin is the input, give input. That input is amplified. So the input is nothing but differential voltages. You are given to differential voltage given to the terminals. So suppose you are giving single input to amplifier. So suppose you are given positive terminal to amplifier, the input is given to positive terminal to amplifier. It is nothing but non-inverted amplifier. So the input is, you give negative input to the negative terminal. So the voltage is given to negative terminal. It is nothing but inverted amplifier. So the first stage is providing the high input impedance, low noise, and you have common mode rejection ratio. So everything is high. So that is the role of input stage. So here the input stage, we are using the transistors. Okay, I already told the transistor, the operation amplifier consisting of so many transistors are packed. You get the operation amplifier. So in first stage, we are uses bipolar junction transistor. It is nothing but BJT, or the metal oxide semiconductor field effect transistor. We are using MOSFETs. We are using BJT and MOSFETs in first stage. In second stage is nothing but intermediate stage. It's nothing but gain stage. This stage is a high gain amplifier, usually implemented with a common emitter, common source amplifier. It's provide the most of voltage gain in the operation amplifier. Obtain uses a current mirror for biasing and load stability. It's providing the load stability, enhancing the open loop gain of the amplifier. What do you mean by open loop gain? Open loop gain is something that you are giving the input without feedback, you can amplify. That is something but open loop gain, right? So in second stage, you are mainly focusing on amplification, right? You are using common emitter, common source amplifiers. It's a high gain amplifier. Here using the first stage, you are using BJT and MOSFET, and second stage, you are using the current mirror for biasing of load, biasing and load stability. In third stage is level shifting stage, shifting the DC level of amplifier signal to match the voltage range of the output stage. So necessary because the way the previous stage may introduce an undecided DC offset. Typically, the implementation uses an emitter follower or source follower with a DC biasing network. So the third stage is purely the shifting the DC level of amplified signal to matches the voltage range of the output. Next stage is fourth stage. It's the final stage of operation amplifier. The final stage is providing the low output impedance, ensuring the efficient power delivered to the load. So implemented as a class AB push-pull amplifier, which reduces the crossover disturbance and improves the efficiency. It provides the high current deriving the capability, matching the op-amp stability, op-amp suitable for different applications. So this is the various stages of operation amplifier. You can amplify the input signal and get an output. So in general, there are 4 stages and but get an amplified output. It's a high gain amplified output get in 4th stage. So the output voltage, the saturation level is the operating voltage is the saturation level. You can amplify up to the saturation level. So the input always you can give from millivolt to volt input, but what is the amplified maximum voltage is 12 volt. 12 volt is the operated voltage is nothing but 12 volt, because you are providing the positive terminal, you are providing the plus 12 volt, and negative terminal you are providing the minus 12 volt. So the positive saturation voltage is 12 volt and negative saturation voltage is minus 12 volt. So this is nothing but your output voltage. The input is always the low voltage input we are giving. You can amplify with up to 12 volt, it is nothing but output. So you can give millivolts range, you can amplify up to maximum of 12 volt. That's the functionality of operation amplifier. So a lot of measuring applications, measuring the sensor, the outputs are connected with the operation amplifier. You can amplify the signals. So what is the summary of the functions of each stages? First stage already told. The first stage is nothing but differential amplification with high input impedance, and you have high CMRR. It's a common mode rejection ratio is nothing but CMRR. The CMRR unit is in dB decibel. So the CMRR is nothing but common mode rejection ratio. It represents dB. It is nothing but high. It is providing the high CMRR in stage 1. Second stage is you are doing the high voltage gain amplification. Third one is nothing but you are doing the level shifting stage. Your DC voltage is adjusted with the help of the level shifting stage. The output is providing the low output impedance in output stage and high current drive. So it is the main functionality of each stages. So first stage is high, it is providing the high input impedance. Second stage is nothing but high voltage gain, and third stage is we are doing the DC voltage adjustment, and fourth stage we are doing the low current low output impedance and high current drive. So there is a different functionality of operation amplifier. You have 4 stages we discussed. With the help of 4 stages, we are getting the high voltage gain in operation amplifier, and with the help of this you are performing the different functionalities. What are the functionalities I discussed? First functionality, you are doing amplification, perform the addition operation, subtraction operation, and then integration, differentiation, and performing the logarithmic operation and the anti-lag operations. So performing the different operations. Thank you.